And we are recording now. All right, let's bring that down. Let's bring that down so that doesn't interrupt us. Okay, what does it say? It says you wish to test the following claim. So you have two statements. And remember, many times one of these statements is the one that you want to prove. You might want to prove HA that is true, or you might want to put try H0. Whatever they tell you is the claim, is what they're trying to prove to be correct. All right. The other thing you have to understand that because we have limited resources at this moment, we can only say two things at the end. We reject H0 or we do not reject H0. So that's basically always our answer. Okay, so let's continue with that. A significant level of 0.06. So this is basically the level of, if we do this, right? This number is 1 minus alpha, the one that goes in the middle, and then you have to determine what kind of test is it, which we will do in a moment. You believe that the population is normally distributed, so that's great. You do not have the standard deviation. In other words, you don't have the standard deviation of the population. That's what it says here, population. You obtain a sample size of n equals 28. That's very important. We're going to write it on the side with a mean of 86.3. Now, this mean is this number, is the mean of the samples. And the standard deviation of the sample is 12.9. Now, they say they don't have the standard deviation for the population, but they do have the standard deviation of the sample, which is just collecting the data and doing it. Now, we have H of 0 and H of A. Because in H of A, they're using this sign not equal, what does that mean? It means that our test is going to be a two-tailed test. So whatever we do, we have to distribute the alpha value in these two places. All right, so we'll do that later. And I don't even think that they ask you to do that because depending on the method that you're using to prove your hypothesis, we'll see later what method they want me to use. At this moment, they ask me, what is the test statistics of this sample? Now, test statistics is, okay, we need to decide, first of all, always, if we're going to use a Z or if we're going to use a T. Now, because they gave me the standard deviation of the sample, now, and I don't have the standard deviation of the population, I don't know this one, and I know that this is normally distributed, so I am forced to use t-value. So the t-value is what we're going to do. Now, how do you get the test statistic? Test statistic means the information comes from the sample. The word statistic also refers to sample, right? We study that right at the beginning of that. Now, we had a formula to find the test statistic. The formula, what is the formula? Is X bar, or you remember,
Mu.
minus
Mu.
mu
Over
divided by
best.
standard deviation
Over zero and
n, right? So we're gonna get that information. That's why it's called sample. You get this from the sample. Um, and we're gonna get it from the sample right over here. So it's gonna be 80, the numbers are right here. X bar is 86.3. Mu is right over here in the beginning, 81.7. Standard deviation is 12.9. And the square root of n, which is 28. Okay, I'm gonna have to use my calculator on the side here. I think I'm gonna do the top 86.3 minus 81.7, and that's going to give me on the top 4.6. I'm going to do the bottom 12.9. Sorry, 12.9 divided by the square root of 28. Okay, that gives me a very long number, which I'm going to say 243.78 and continues. Okay, now sometimes in the book or in Lumen, they use 4 decimal, 5 decimal, but if you use all the decimals, then your answers can be a little bit different. At this moment, I am not going to simplify the denominator. I'm going to use it the way it is. As big as it is, I'm going to use that 4.6. I'm going to divide it by that long number, and the answer is going to be, sorry, I'm going to write it here for you because I can't. The answer is 1.88 according to my 689, and it continues. Now, they say report answers accurate to 3 decimals. So I'm going to use 1, 2, and 3. Now, because 3 is 6 and the next number is 8, so my number is going to be 1887. Point. Look at the point there. So that is the test of statistics. Is everybody okay so far?
Yeah.
Okay. Now let's go and see what's the next question. All right. I'm going to copy the next question. Now it's asking me what is the p-value for this. I'm going to go to a new page so that we don't have that problem. Now, what is it that we found? That is very important that we know what we found. So let's copy and a little piece of board here. We copy that we had a number. Remember, this is a two-tail test. So the number that we found was the t-value that we found was 1.887. So let's see that this is 1.87 is right here. That's all the green area. And this is negative 1.887. And the same thing, this is the positive 1.887. This is the positive side. That is the negative side. Now, the p-value is the area that we have here. This is called the p-value. The only problem is that the p-value in this case has been distributed into sections. So if we found this section here, we have to add this section here because it's the type of test that we're doing is called a two-tail test. Now, how do we find that area? That's called the p-value. How do we find that area? Well, we have to use a calculator to find that area, right? This is like inverse of t. Inverse t. Why inverse? Because we don't know the area. Oh, actually, this is not the inverse because we have the value here, so we don't need that. Sorry. No, so let's scratch that. What we need to do is to find this area here. Okay, so I'm going to paint it red, and I'm going to do the left side because that's what more calculators do it. So the left side is equal to the right side anyway. But it's easy for calculators to find the left side because this is the beginning. So what is it the calculator is going to ask me? The calculator is going to ask me what is the lower limit. In other words, where is your area begins? Also, it's going to ask me for the upper limit. In other words, where is the area end? And it's probably going to ask me for the degree of freedom. Now, I don't know I'm going to write it there just in case, and then we'll see what other questions they ask me. What is the lower limit here? Because we want to find this little piece of land here. Like we need to know the beginning and we need to know the end. So what would be the beginning?
Minus infinity.
Minus infinity. So this is the way we write it. Now, the end of this little piece of land here is negative 1.887. And the degree of freedom is how many sample size we have minus 1. The sample size was 28. So the degree of freedom is n minus 1. That would be equal to 27. Okay, so we are ready to go into the calculator and to ask the calculator, what is that value there? What is that number? Okay, so we're gonna go to the calculator and we're gonna do that. Let's see if I have it. That I didn't have. Maybe I have ready here. That's not the class, but we can look for your class. Okay, that is your class, and we want to find t values, t scores. I think that's the one. Let me see. Okay. Sorry. No, that's not the one. Because that's not going to give me, that doesn't give me the beginning and an end. I have to have a beginning and an end. This will just, let me see if I have more down here. No. This just is going to calculate the t value of the number. So we're going to go to a calculator where we are able to do the beginning and the end of the situation. Do I have something like that? I hope I put it. Oh, maybe this one? No. No, this is the one that we always do. Oh, no, because this is what we want. And here we have the significant level, but that's what we need to find. We need to find the significant level, which is we don't have. I thought I had a calculator for that. Does anybody have used any of my calculators to find this?
I couldn't find any calculator.
You couldn't find any calculator. Ooh, so maybe I need that calculator. Sorry about that. Otherwise, I have to go to the calculator. Let me see if this will give you. This should be random variable. We need to find the t-score. We need the no, let's see, because these automatically assume from left to right. So the degree of freedom was 27, right? So I'm assuming that it's not going to ask you for the left side because he already knows that the left side. So it's only asking you for once. The problem would be if we would need to find between two numbers. Okay, I'll see if I can find another calculator. But let's see if this one was working. Remember the t-score was 1.887?
Yes.
All right, let me see if it worked. Actually, it was negative, remember, because we're doing the negative side, right? So we got it right. We're going to put a negative side there. Oops. Let me put it again. Negative 1.887. Okay. You see, if I do the positive side, it does the entire area, which we don't want. So now we see.
You have two ways.
Yes. This one doesn't work when I do it again. So let's do it again. I'm sorry. 27, and the t-score will be minus 1.887. Let's see if it calculates it. Maybe it did calculate it, but I don't know if this is the right number. Did anybody, if you did it in your calculator, does that work? Let me do it in the yellow calculator. Let me do it in the yellow calculator because I'm not sure if this is the right one. So I'm gonna see if I can find a different calculator for you guys. But in the meantime, let me see if I can open my calculator and do it in there, in the regular yellow calculator. Give me 1 second. There you go. I didn't realize that I didn't have a calculator for that. Sorry. We're gonna go to statistics. We're gonna go to distribution. We're gonna go to t-value. We're gonna go, see, this one doesn't have inverse, but I don't need the inverse at this moment. See, this one asks you for the lower, the upper, and the degree of freedom. So that's what we want. And the lower was negative 10 to the power of 10. That's the left side. Now, the upper was negative 1.887. Are we okay with that? Now, DF is the degree of freedom, which is 27. And let's see if we get the same answer. Oh, we do get the same answer, 0.03. Oh, so this one was right. We get the same answer. Okay, that's good. So let's write that down, right? So actually, this is the same thing. So you have a calculator there. It just doesn't have the left side because it assumes that the left side is always infinity. Or if you do it on the positive, it assumes that they always read from left to right. So that's good. All right, so that's the answer. Let me write it down and let me copy it from here. So let's write that down, put it over there, put it on the current page. So that area is that. But what is that the complete p-value? What do you think? Is this the complete p-value? The answer is no, because we have two sizes, right? We have, remember from the very beginning, I told you that this piece is the same as this piece because the problem was a two size. How do you know it's two sides? Because they're using the not equal. So when they say no equal, you have to use both sizes all the time. Okay. So the p-value is basically the addition of those two values. So we have to put 0.0350 times 2. So if you take this value here, it's going to be, that value is going to be 0.035 plus the other side, 0.035, and that's going to give you 0.07. That's the answer there. Okay. Are we okay? Sorry, I didn't know. I forgot that calculator works. Very good. And online. Questions so far?
No.
Okay. So this is basically a calculated question, and we're going to go back to see what the next question is. I think it has more questions. Problem. It's Lumen. Okay. The p-value is, so we're going to do the p-value. We're going to do this too because it seems easy enough. We're going to go to a new page. Okay. All right. Now, we're going to have to write the p-value here. The p-value that we found, it is 0.07, right? So, and alpha, I don't know if you remember, they gave me alpha for this problem, and alpha was 0.05. Okay, 0.05. So, the p-value is less than or equal to alpha. Is this less than this number?
No.
Greater than that number. This is greater. So that's my answer right there. Greater than. Okay, now because this is the situation that we have, then we can answer the next question. The test statistics leads to a decision. In other words, all the work that we did with the test statistic lead us to decide, can you help me which of these three we are going to do?
Fail to reject.
Fail to reject. Accept, no. Reject, no. We only have two choices, reject or fail to reject. So that's the answer because the p-value is greater. By the way, the method they're using here is called the p-value method, where you compare these values. You can do that. There are three methods that we have learned: the traditional, the p-value method, and the interval method. So, is there another question on this? Oh yeah, there's one more. Okay, let's copy that into our same page. I think we have a little space. Current page. Okay, as a result of everything that we do, now they ask us to do a conclusion. Maybe you can help me. Tell me that if we put numbers on this 1, 2, 3, and 4, maybe you can help me with that conclusion. Which one do you think is the right one?
The second one.
Okay, let's talk about, we have h of 0 from the very beginning, remember, and h of 1. H of 0, I forgot what was h of 0. Let's go back a little bit. 81.7 is the number, 81.7. 81.7, mu is equal to that, right? And this one was mu was not equal to 81.7. This is the claim. In other words, this is what we wanted to prove. But the only thing that we were able to do was we do not reject this. Do not reject. So if we don't reject this, then definitely this doesn't come true. Let me put it in other words, we accept it. Basically, if we don't reject it, we accepting it. So one of these two is the one that we accept, and the other one we don't. So if we accept this, what happens to this?
Reject.
Yeah, basically, we're not gonna use those words, but that's basically what you're doing. We are not rejecting this, so we have to reject that. The two of them cannot be true at the same time. So how we able to do that? Because we look at the sample evidence, whatever they gave me, the sample evidence helped me make that decision. The sample evidence made me do that decision. So sample evidence is the statistics, right? Is the statistics. That's what basically made me make the decision. So let's read everybody and see what is the best answer. There is sufficient evidence, in other words, there's enough evidence to warrant rejection. In other words, to have enough evidence to reject of the claim that the population is not equal to 81.7. There is sufficient evidence to warrant rejection of the claim that the population mean is not 81.7. What do you think about that? You have enough evidence to warrant rejection of the claim that the population mean is not equal to 81.7. Is that what the evidence gave you?
No.
No. The only thing that you have in this type of exercise is enough evidence to reject or not reject the h of 0. You can't say anything about anything else. That's the only thing that I have shown you. You only have two choices, and I said that at the very beginning. You only have a choice to reject h0 or not reject h0. After that, you can make any conclusion that you want, but that's basically what you have. So you didn't collect all this evidence to be able to answer anything about h of 1. So we cannot pick this one because that's not what we were doing. The evidence only can show you two things: h0 okay, h0 not okay. All right, next one. There is not sufficient evidence to warrant rejection of the claim that the population mean is not equal to 81.7. Again, this is talking about the not equal. They're talking about H of 1. We are not talking about H of 1. We don't collect information on any of these problems. We don't collect information regarding anything other than H of 0. So we only have two choices here. Would you mind picking one of the choices?
Mm,
Which is the best, basically, right?
There is no sufficient sample evidence.
I will say that too.
There is not sufficient sample evidence to support the claim that the population mean is not equal to 87. This one is the sample data supports the claim. The sample data supports the claim that the population is not equal to 87. So, which is the two, 3 or 4? Which is
Sample data supported.
1?
Mm,
Okay, what is it that you're doing here? The language is kind of difficult. Number one, I like this one because it tells you specifically that you took the sample evidence. That's a very important phrase, sample evidence. This doesn't say sample data. Sample data can be a lot of stuff, so we don't know. It has to be very clear. So if you do not reject this, if you say this is okay, what are you saying about the claim? Because that's what they want to know. If they say this is okay, basically they saying this is not okay. If this is okay, this is not okay. That's basically what they're saying. So let's read.
Oh, it is number 4.
There is not sufficient sample evidence to support. Remember that they want to support. They support the claim that's the claim. To support the claim that the population mean is not equal. So basically, because you say this is okay, you are saying that your sample evidence told you that this is not okay. So that is the right answer. Okay, this is probably the hardest of all of them because the other one is basically math. This is the one that, but I can tell you that the key phrase here is sample evidence. They talking about the claim, but the reason that they talking about the claim is because basically they're using the fact that this is okay and this is not okay. Okay. Anything else with this question?
No.
Okay, there was another question regarding that they sent me. If there's no question with that, I think it was question number 8. So I have question number 8 here, right? It was that question number 8, then the other one?
Yes.
Hello? Question number 8? Right, okay. All right, let's take a look at question number 8. Let's see what it says. There's a lot of parts on question number 8. So maybe we can do this without going, maybe I'm not going to be lazy, so let's copy this into my current page, new page. Okay. Suppose that BC Financial Aid allots a textbook stipend by claiming that the average textbook at BC bookstore costs 73. So this and the name of this place is claiming that the average textbook at this bookstore costs 73.73. Now, when they use the word average, so you know that they're using what symbol for average? What is the symbol that we should be using? We only have 3 symbols for this. We have the proportion, we have mu, and we have standard deviation. Those are the only, this is a very simple decision because basically you only have to decide between 3. Now, because they said the word average, and when we're talking about deviation, then it has to be mu. So one of the question is, what is the average of cost 73.73? Okay, so the average is equal to 73.53. You want to test the claim Okay, you want to test that claim. So this is the claim, basically. The null and alternative hypothesis in symbols will be. Now, because we're using mu, definitely this is not okay, this is not okay, and that's not okay because they're using p. Now, let's talk about what's not okay either. Well, mu here for h0, they're using greater than or equal, which could be, it could be because they're using the word equal. The only problem is that nowhere here in the question they tell you that it's greater than. It just say that it's equal to 73.3. So definitely this is not the one, or definitely this is not the one. So they only have one choice. This is h of 0, and h of a is the opposite of that. Okay. Is everybody okay with the first one?
Yes.
Yes.
Okay, so let's move on to the next question. Okay. All right. This is related to the first question. So, new page. The null hypothesis in words. So they want to know this in words. How would you say this in words? So which one is the best way to describe that statement?
Mm.
The first one.
Mm-hmm.
Mm-hmm.
Well, definitely we're not using the word greater, so that's not good. The average price of a sample, the average price of textbooks in a sample. This is not a sample because if you're using mu, this is not a sample, right? So that's not okay because they're using the word sample. The average price of all textbooks from the store is less than. Definitely, they're not using the word less than. They're not using that symbol. The proportion of the word proportion is wrong because now we're not using p, we're using mu, and we said that this was the value. So this is the correct one. Questions there?
No.
Okay, let's move on to the next one. Oh, okay. Maybe we have to copy the whole thing. I don't know. Hopefully, I'm not grabbing too much. Okay, let's read. Based on the sample of 170. So now they're talking about sample. Now we're going to do sample work. All right. Sample of 170. That's good. That's a lot of samples. At the store, you find the average. So this is the average for that sample of 69.3. And a standard deviation. This is the standard deviation for the sample, 22.6. Okay, the point estimate. What is the point estimate? I explained it in the last class. The point estimate is basically what?
Average.
The average that they're given, the given average. The point estimate in this case is the given mu, because they, not mu, sorry, the given X bar. That's the best estimate that we have, 69.13. Now, if they would have talking about proportions, then that would be the given proportion would have been the point estimate. Point estimate is where you're going to begin your process, basically. And this is the only thing that they're giving you. So we're going to use that as starting point. Now they say 90% confidence interval. Use Z values. Very interesting that they ask you that use Z values because we don't have mu. Sorry, we don't have sigma, but they still ask you to do the Z value. Does anybody know why they are asking you to use Z values? Because otherwise you will use T, right?
Mm-hmm.
If they don't tell you, you will use T. The reason why they will confident say they use Z values is because the sample size is very large. It's 170. Usually T values have very small values, less than 30. Now, if they don't say in parentheses to use Z value, then do not use Z values. You understand? Don't use Z values. if they're not asking you to use it. But in this case, we're safe because they're asking you to do that. Now, okay, we're gonna use a Z interval method. I'm sorry, a confidence interval method. What is the confidence interval method? Is this value here,
See. Yeah.
right? The moment that they use this confidence interval, that's basically what they're asking you to do, right? And we do have a lot of this information. Also, we know the formula for E. Let me use a different. Okay, now because they're asking you to use Z value, this would be Z value, right? Alpha divided by 2 times, oh, that looks like a 3, times what? Do you remember?
Sample divided radical.
Sample
Standard
divided by
deviation, correct, divided by the square root of n. All right, so basically we have a lot of the stuff that we need is there. Okay, let's take a look at what we have and what we don't have. X bar, yes, we have it. It was given to us as 69.3. Okay, we have this value, 69.3. We do have mu, basically. I think that they gave me mu as 73.53. I don't know if you remember that from the very beginning that we talked about. So now we need to find E. Now I'm going to go to a different page and then I'm going to come back here. E depends on this number that it says 90%. So we're going to go and going to move forward and we're going to go back to this to find E. So let's open a new page. Now E in this case is Z alpha divided by 2 times standard deviation and the square root of n. And they want this to be a 90%. 90%. So we need to do all of this. Now, 90% means that that's what's in the middle, 90%. Now, do you remember if this was a 2 test or a 1 test tell?
2 tests.
2 tells, right? So that's, we have to do it because remember that we're using the symbol not equal. So that means that we're doing both sizes. But regardless of that, we always like to make a picture to make sure that we understand that. Now, what is it that they want to know? Well, if this is 90%, how much is in each one of these?
0.5.
0.
0.05.
Because if you add the 3, there has to be equal to 1. So we need to find this value here, which is Z, alpha divided by 2. We need to find this. One of these is okay. It doesn't matter. We prefer the positive because, you know, we don't use negative. But if you get this one, just use the absolute value of that number. Now, let's see what we have. We don't have this number, but we have the standard deviation. I believe that they gave you the standard deviation 22.6. So that's 22.6. We also have N. N, it was 170. 170. And what we don't have is this. So we're going to use the calculator to find that value. So we need to know. Now we have the inverse. Remember, we have the area, but we don't have the Z value. So we need to find the inverse. So let's go to our calculator and find the inverse. I think that's the calculator that it works very slow. Let's see. Okay. No, that's a Lumen question that I have for my other classes. All right. I hate this thing when it comes out because it doesn't want to get out of there. This is such a painful, finally disappear. Okay, so we want a critical Z value. Let's see if we have critical Z value. I think I gave you, there you go, critical Z value. Critical means that I have the area and I don't have that. Okay. All right. What is the significant level? You can do one on the left or you can do one on the right. So I don't know why this is not working. Oh, I think it started working. All right, what do we have on the left? Always try to work on this calculus on the left. I think it was 0.5, right?
Mhm.
And this is left tail. You can also do right tail if you, it doesn't really matter. Left tail, and because this calculator will take care of all the details. So let's do the calculations and see what is that Z value on that side. It's doing the work. Yeah, while I'm doing this, try to think of if there's any other questions that you may have.
Why did
Okay.
you use right tail or left tail?
Okay. Give me 1 second. Let's write that number. You see that number? Now the calculator right now is reading from left to right up to the point that we want. And what was the point that we want? 1.64, negative 1.64. So the calculator is saying that if you go from negative infinity all the way to 1.64 negative, the red area, that piece of land, is going to be 0.05. Now, what happened if you want to do it on the right side? It's the same thing. It's the only thing that this calculator is very good because the calculator will do the limits for you. You don't have to do it. Look, we are gonna basically open it up again, and instead of doing a left tail like we did, we're gonna do a right tail, and you will see that the answer is the same thing because the calculator is doing all the little details for you, and it's finding out that on both sides is I didn't. Okay, so let's
And
delete
we're
that.
not allowed to use two tail.
No, because the two tails, then you will have to divide this. If you want to use two tails, you could. I'm show you in a second. Let's calculate now the right tail, and I'm going to show you how to use the both tails in a moment. I think it's doing the
Okay.
calculations right now. That's a very good question. Okay, so now it's doing the, I think it did the right tail. Now look, it's this calculated. You got to clean it and do it again. But if you, let me go back to my, and then I'll do it again in the calculator. Give me 1 second. This one will be negative 1.64, and this one will be positive 1.64. Now, what happened if you want to do two tails? If you want to do the two tails, then you have to add these two numbers together, and then you're going to get 0.10, which you could do it right away. Now, we got to close this because this calculator doesn't work like that. And now we're going to do two tails. Now, if you want to do two tails, then you got to do 0.10, right? And then you do right tail. The calculator does the division. I'm sorry, two tails. So now it's going to take this number, and because it's 2, it's going to divide by 2, and it's going to distribute it left and right. So let's do that. Right, and I think it's calculating right now. Last time it worked faster. The only problem is every time you do it, this calculator apparently you have to close it and open it again. All right, let's see. You see that now? Oops, you can't see 1.64. Now you see that on the left is negative 1.64. On the right is 1.64. 1.64 on the left, 1.64. So it all depends on this number. If you want this number to be only on one side, then you got to make it 0.05.
Oh, okay.
If you want to do it on this side, you got to do 0.05 right side. But if you want to do on both, then you got to put this, and then you get the nice picture because then you get both sizes, right? Okay, so we know that the value is 1.64. 1.64. We always use the positive side. Now we got to do this. We're going to multiply this 2, and then we divide by that, or divide it, whatever word you want to do it. All right, so if you have a calculator, you can work with me. I'm going to do 22.6 divided by the square root of 170. And that's going to give me a very long, this is going to give me a number like 1.7333 something times 1.64. So I'm going to multiply these two basically. and see what we have. 1.64. I'm trying to use as many decimals as is possible. 2.842679. Wow, that's a long number. It is longer than that. So now we found the error, and we can go back to this place here, and we found the error. The error was 2.842679. And we're going to subtract it here, and we're going to add it here. 2.842679. And then we're going to have an interval, which is going to go from here to there, right? So let's see what we get on this side. I'm going to save this in a variable. So I'm going to do 69.13 minus all that number. And it's going to give me 66, this side over here. I'm going to put it in a different color. It's going to give me 66.287. Now, I think in the, they only want 3 decimals. That's why it's giving me a longer number, but that's all right. Like I said, I'm not going to go crazy. That's mu. Okay, and then this side is going to be 69.13. I should have read that they only want 3 decimals. Sorry about that. So this side is going to be 71.97. Okay, 26. Now I'm looking at the answers in the actual book, in the actual Lumen, and the answers are a little bit different here. It's because they're using only 3 decimals. Remember, I should have only used 843, and that 28. If I use 2.843, I think my answer would be a lot closer to what they say. Let me say 69.13 minus 2.843. 66. We use 69 point, what is it that they want? 69.13. Did I put it? 66.28. I get 28. So they want 27. So it becomes very closer and closer. It doesn't. I'm not gonna go crazy, but you guys may have. You guys are gonna go a little crazy because I'm using the numbers. You have to be able to use the right numbers, otherwise you're not going to get the right answer. But don't worry, I'm going to go into the homework and make any corrections. So the number that they actually use online is 6913. I'm going to write it for you. On the side is 6627, right? And the other one, they use 71.99. Now, as you can see, we came very close here to this. There must be some decimal that we are not using correct. I think that the error, they use a different an approximation, but that's okay. Don't worry. In the final exam, this is not going to be marking correctly for 1 decimal, right? Or yeah, 1 decimal. Now, based on this, now remember what you have in mu. Mu is this number here, 73.53. Now you have to ask yourself if this is true or not.
No, that's not.
Is 73 between 66 and 71?
No.
No. This is not true. So what happens if it's not true? What do we do on the last question? We fail to reject, or we reject?
Well, reject, I guess.
Reject, because if this is not true, we can't accept anything that is not true for the null hypothesis. So that's the answer, right? But this is the only complication that I see with the decimals, but don't worry about those little decimals. Okay, questions? Miss Kindep, was I able to answer your question?
Yeah, thanks.
By the way, this is a different method. This method is called the interval method. So this is, we show you the p-value method today and the interval method. The other method, the traditional, they don't use it that often, but you could, we learn it, and it's somewhere in your videos.
Can you
Okay.
repeat why you rejected the null hypothesis, please?
Say that again.
Can you repeat why you reject
Yes,
the
yes,
null
yes,
hypothesis?
yes. The null hypothesis is based on the fact that this has to be true. Now, these are the values that we got. This is the values that basically the textbook got. You can either use this one or that one.
Mm-hmm.
And mu was given to us, remember, from the very beginning?
Yeah.
Okay, let's just use that. This is the lumen numbers, but you can use your numbers and still want to give you the same answer. My question is this number 73 in this interval? Is 73 between 66 and 71?
No.
No, so it's not true.
Okay.
In other words, your interval that you got from the sample does not contain the mu from the problem. So if you don't contain, it has to be at the end of this exercise, your interval has to be true in order for you to accept h of 0. If the interval is not true, then you reject h of 0.
Okay. Got it.
This would have been the same answer if you would have used any other method, the traditional method or the p-value method. With the p-value, you could do this with the p-value also, right? You can do the p-value, but the only difference is that you would have to use the method, the process that we use at the very beginning of this lesson, which should be the same. Okay. Anybody else?
Taking questions from the textbook, and we'll have the textbook.
Yes, I mentioned last time that those questions, do not worry about those questions, because I don't, those are mistake. Lumen over the years has been trying to, what questions are those? Can you tell me?
Question 9 and question number 10.
Okay, let's look at question number 9. We'll see what it says. Do the sample price strong support the claim that oh yeah, definitely we don't have that, right? So don't worry about that one.
Okay.
And let's take a look at 10. No, question 10. I don't know why they do that. We don't have access to a textbook. Last time I mentioned to them and they said, I'm sorry, that was a mistake. Over the years, they've been erasing those questions. Remember, Lumen is a very big company and it has a lot of colleges. So some colleges probably use books and some others don't use books. So over the years, they've been trying to erase the questions that don't belong to La Guardia, for example. That's probably from another school. Okay. I think that we did almost all week 11 homework over the last. If you don't have any questions, then go back to work and make sure you do the questions from the review also, right? Those are very important too, the review. You have to finish all the homework from Lumen. That's very important because that's part of your grade. That's your final grade from La Guardia. And I don't know if you noticed, but next week is the last week for this class. After June 4th, I have to finish the class. And this is not high school where they give me time to, give me some more time, Mr. Pineda, to do my homework. I can't. They have a deadline. And that's when the deadline will happen. Okay, so make sure that by June 4th, you're ready. You finish all your homework from Lumen. You finish all the review and you're ready by June 4th. I don't know if that's when they're going to give me the test, but they told me that they're shooting for that day. Let me see if they have put any tests already in there. My test will appear here. I'm not going to show it to you, but it's not there. So they told me that it's going to be here at the very beginning. There's going to be final tests. And so please make sure that you are ready for that day. Okay?
Okay.
Okay.
Tomorrow we'll meet again. If you don't have any exercises, I will give you some exercises. I have some exercises ready for you. So please bring some questions. We'll meet every day, Even if it's a small amount of time, we'll meet every day to make sure you don't have any questions.
Okay,
See
mister.
you tomorrow.
Okay,
Tomorrow then.
Okay.
thank you. Bye.
Have a good day.
Bye-bye.
Bye,
I have a
Mr.
question,
Take care.
You do.
Mister.
Yes.
We don't have to do question 9 and 10. Oh,
Say that again.
we have to do question 9 and 10.
No, you don't have to do question 9 and 10 because we don't have the book. You don't have to do that.
Okay.
Don't worry about question 9 and 10.
Okay.
When I give you the grade, I am not going to, the general grade, I'm not going to take points off from that. I usually give you another 5 or 10 points at the end for all your question, for all your homework. So let's say you all your homework, you get 60 for all your average of questions from homework 1 to 11. You get a 60 average. I'd add another 10 points to that.
Oh, okay.
So don't worry, because I'm not going to go question by question. I just give you 10 points
Okay.
as a way to correct all the errors that they have.
Okay, mister. Thank you.
All right. Keep working. I like the way that you're working. Make sure that you keep working and understand these things.
Okay, mister.
All right. I'll see you.